Hello friends, myself Dr. Divya Ghildial in continuation with my lecture series for AKTU Energy Engineering Physics Btech first year paper. I am continuing with quantum mechanics. What did I tell in my previous lecture? I told you about Stephen's law, Wayne's law, Rayleigh-Jean's law, black body, and I derived an expression for average energy of Planck's oscillator along with one numerical on Wayne's law. Now we come to the next heading, wave particle duality. Before we begin with it, let me take a quick recap of your certain concepts which are required for you to be clear with before you start understanding this unit more clearly. You must be familiar with the fact that light shows dual character. At times it behaves as a wave and at times it behaves as a particle. What are the examples where light is showing wave character? Example is interference, diffraction, dispersion, polarization. All these optical phenomena show the wave character of light. That means light is traveling as a wave. Certain other phenomena, if we talk about, like photoelectric effect, Compton effect, in such phenomena, light shows the particle nature. What about we imagining a wave traveling with lots of particles in it in the form of a wave? Think this is how a wave is going and it has large number of particles in it. Quantum. Quantum word in itself means large number of particles. Quintal. 1 quintal, 100 kg is equal to 1 quintal. So if I imagine such a wave, then according to science criteria, it will be known as matter wave. Louis de Broglie, the very famous scientist, gave an expression which combined this whole character of light showing both wave and particle nature by his very famous expression, lambda is equal to h upon p, where h is Planck's constant and p is momentum. We know from the basic concept of science that we cannot equate an equation unless and until the quantities on left hand side and right hand side do not carry the same units and same dimensions. Now have a look at this expression. The left hand side is carrying the dimensions of wavelength, meter, centimeter, kilometer, and the right hand side is carrying the dimensions of Planck's constant divided by momentum. Momentum, when any certain particles will fall on a surface, they will create certain type of pressure on it. Rate of change of momentum will exert a force on it as per Newton's law and the formula F equal to dp by dt, where force is rate of change of momentum. So what is this expression of Louis de Broglie actually doing? It is combining both the wave nature and the particle nature. And it is stating that a matter wave consisting of large number of particles traveling in the form of a wave, every particle having wavelength equal to lambda equal to h upon p. That is lambda 1 equal to h upon p1, lambda 2 equal to h upon p2. So this is what the whole concept of wave particle duality is all about. This now you will be studying, and in this heading, numericals are often asked on the formula lambda equal to h upon p. So you should be memorizing 4, 5, formulas for lambda equal to h upon p, so that you are able to attempt the numericals. Section A, usually they ask, write a short note on dual character of light. So you will say light shows dual character. At times it behaves as a wave, and at times it is behaving as a particle. Phenomena of interference, diffraction, and polarization are explained by wave theory. Photoelectric effect and Compton effect are explained by particle nature, and the ability of electromagnetic radiation to manifest itself as a wave or as a particle is basically the wave particle dualism. Dual means two. So what did de Broglie state about matter wave? De Broglie stated that a free particle with mass m moving with speed v should be having a wavelength lambda related to its momentum exactly in the same way as a photon, or a photon light of frequency mu. Now, from this formula, E equal to PC. You have done this in relativistic mechanics also. Energy is equal to momentum into velocity of light. You can refer it there. And the very famous Einstein's equation, E equal to h mu, where h is Planck's constant and mu is frequency of light. We equate E equal to PC equal to h mu. So we get P equal to h mu by C. Now we also know the formula that velocity is equal to frequency into wavelength. V is equal to F into lambda. So wavelength of a photon can also be given by, we put the value of V mu frequency equal to C upon lambda. So if in here you put mu equal to C upon lambda, C and C will get cancelled and you will be left with lambda equal to H upon P, the very famous de Broglie equation, which is combining the dual nature. Now, P equal to mass into velocity and lambda equal to H upon P, or you can also write momentum is equal to mass into velocity. So once again, have a closer look at the above expression. The left-hand side terms are involving all the wave-related aspects. The right-hand side are involving the particle aspect, and Planck constant is playing as a bridge between both these characters of the dual nature that we are studying today. Okay, now this expression is very useful for your numerical point of view. What all maximum tricks that can be asked are that you will be judged on the basis of units of lambda, angstrom, meter, centimeter, or with momentum, the mass unit of kg, grams, etc. So other useful forms of the above expression which we can have are, you only memorize them. Derivation is not required. And please remember, one numerical for sure will be there from this expression. The question will be as such that define de Broglie wavelength and then numerical attached to it, which I will discuss with you very soon. See, lambda equal to h upon under root 2 me, that is mass and energy. Lambda equal to h upon under root 2 m q charge v volt. Lambda equal to 12.28 under root v in terms of angstrom. So you have to memorize these formulas for your final exam. Again, I am telling you, numerical can very well be expected from these formulas, where numerical will be like potential difference is so much, find the de Broglie wavelength. Numerical will be such that the charge is so much, find the de Broglie wavelength. Numerical will be energy is so much, mass is so much, find the de Broglie wavelength. Okay. So please memorize these formulas quickly. Lambda is equal to h upon p, where h is Planck's constant, p is momentum, momentum is mass into velocity, lambda is h upon under root 2 me, where m is mass either of the given electron or proton. They will give you the value in the question paper. E is the energy either in electron volt or joule. Lambda is h upon under root 2 mqv, where q is charge, v the potential difference. Lambda is 122.28 under root v, where v is the potential difference. But then this value of lambda comes in angstrom. So what are the properties of matter wave? Matter waves are not electromagnetic waves. Don't confuse them with electromagnetic waves, because matter waves are also, now we will see how group velocity and phase velocity comes under matter wave itself. Secondly, they are generated only when the material particles are in random motion. Velocity of matter wave will usually be found to be greater than the velocity of your EMT waves, and matter waves are associated with particles. So there is a difference between matter waves and electromagnetic waves. First, what we will do, we will derive a general wave equation to understand this matter wave further, because we first need to understand two terms, group velocity and phase velocity. See, the general wave equation in the direction of increasing x and vibrations in y are given by y is equal to a cos 2 pi mu into t minus x upon w, where a is amplitude 2 pi 3.14, mu frequency, t the time period, x the displacement, and omega the angular frequency. So, the angular speed of the wave. It travels it at a distance x in time t. We know that v is equal to f into lambda. So in case of angular frequency velocity, it is equal to omega is equal to mu into lambda. So we put this value of omega here. Then this expression becomes y equal to a cos 2 pi, mu comes inside the bracket, t minus x t divided by omega. Instead of that, we have put mu into lambda. So this mu and mu has got cancelled and we are left with this. Phase velocity of wave velocity is then given by mu lambda, multiply and divide this expression by 2 pi. Why am I making you multiply and divide it by 2 pi? So that instead of linear form, I can write it in angular form. See, linear frequency is mu, no problem, but angular frequency or angular velocity is 2 pi mu. So there is no harm if I multiply and divide this expression by 2 pi. So this becomes multiplying and dividing by 2 pi. We introduce the wave number k also, which is mathematically given by 2 pi by lambda. So I have just played a very short trick of multiplying and dividing it by 2 pi and writing it in terms of omega divided by k. Group velocity u of a group of waves is given by d omega by dk. That is why I made you multiply and divide by 2 pi. So the group velocity may be greater or less than the phase velocity. It depends on the manner in which the phase velocity is varying with the wave number. Here actually omega and w are having the same form. When omega is equal to mu into lambda and lambda is the de Broglie wavelength and mu the frequency. Now, in order to find out an expression which is connecting group velocity and phase velocity, we will introduce the term of energy. E is equal to h mu and E is also equal to mc square. E is h mu as per Einstein's relationship and E is also mc square. We equate both these expressions. We get mu equal to mc square upon h. Putting this value In the expression for omega equal to mu lambda, we get, see, for mu I have put mc square upon h, and for lambda I have put, as per de Broglie definition, h upon p or h upon mv. So omega into v is equal to c square. This is the relationship between group velocity and phase velocity. In general, I will make it more clear to you actually what is this group velocity, phase velocity, multiple of which is equal to c square. See, imagine a matter wave, that is, what is a matter wave? Consisting of large number of particles, which is traveling like this in the x direction. Now, matter wave is going to be a big wave because it is having large number of particles in it. Every particle will have de Broglie wavelength, and we cannot predict with full confidence the full motion of these large number of particles. We will have to take into consideration few particles which are in the same phase and few which are traveling in, say, a general form of group. So probability statistics is applied when you take large number of particles into consideration, according to which the matter wave travels. So group velocity, that is when you are in a group. Phase velocity, that is when the particles under consideration are traveling in a constant phase. Multiplication of the two is giving us the square of speed of light. This is a relationship between phase velocity and group velocity. Let us quickly do a numerical, because numerical on the formula lambda equal to h upon p or other forms of this expression is very important. An electron is moving under a potential field of 15 kilovolt. Calculate the wavelength of electron waves. Now, from our concepts, we know that the de Broglie wavelength is given by 12.26 divided by under root V. V has been given to us as 15 kilovolt. I told you earlier also, first try to normalize the units. Now see, 15 kilovolt, that is 10 to the power of 3. So this becomes 15,000 volts. So lambda is 12.26 divided by 15,000. This comes out as, and this answer will be in the units of angstrom. So lambda is 0.1 angstrom. Next numerical, this numerical has often been asked, and it is very important numerical from your AKTU point of view. Find the de Broglie wavelength associated with a proton moving with a velocity equal to 1 upon 20th the velocity of light. So see, from de Broglie concept, lambda is equal to h upon mv. It is given that velocity is 1 upon 20th time the velocity of light. So v is c divided by 20. C is velocity of light, 3 into 10 to the power of 8. You divide it by 20, you get 1.5 into 10 to the power of 7 meter per second. Mass of proton is 1.67 into 10 to the power of minus 27 kg. This will be given in your question paper. Planck's constant H is 6.64 into 10 to the power of minus 34 joule second. Putting all these values in the expression for lambda, we get lambda is equal to 6.6 into 10 to the power of minus 34 here. H is this much. M is 1.67. So M is 1.67. V is 1 upon 20. So 3 into 10 to the power of 8 divided by 20 is 1.5. Putting these numerical values, we get the answer as 2.63 into 10 to the power of minus 14. So how will the marks be given? You will get 1 mark full for writing lambda is h upon mv. You will get 1 mark if you write velocity is 1 upon 20th the velocity of light. You will put all these constants and their values correctly in the expression. You will fetch another 1 mark, and last 1 mark if you are able to solve it correctly, the numerical values and the expression. Okay. Find the de Broglie wavelength for a material particle of rest mass m0 and charge q accelerated from rest through a potential difference of v volts is given by this expression. Okay, we will use two equations of relativistic mechanics to solve this. We have done in relativity. You can refer to my relativity lectures. E square is equal to p square c square m0 square c to the power of 4. This I have explained in relativity how we get this expression, which is combining the momentum, rest mass, energy and velocity of light. Okay, kinetic energy is equal to VQ. So the total energy becomes equal to the kinetic energy plus my rest mass energy m0 c square, where m0 is rest mass. We have done it in relativity. So we put E and EK, we are putting EK equal to VQ. So VQ, voltage into charge, plus m0 c square. We get p square c square in this side of the expression, e square minus m0 square c to the power of 4. Instead of e square, we write vq plus m0 c square. And then we square the right hand side of my expression, open the terms, simple subtraction, and we reach the answer. This derivation is also important. It has often been asked in section C. Can a photon and an electron of the same momentum have the same wavelength? Compare their wavelengths if the two have same energy. This question has also been asked. Momentum of electron is given by h upon lambda. Lambda is h upon p. So p is h upon lambda, where p is momentum. Momentum of photon, ph is equal to lambda h upon lambda p. If electron and photon are having the same momentum, then lambda, we are saying that they are having the same momentum. We will equate these two quantities. H and H, Planck's constant, will get cancelled, and we will have lambda E, that is wavelength of electron, is equal to wavelength of photon. De Broglie wavelength says that lambda is h upon mv. So E is half mv square. Mv, 2 cross multiply here becomes equal to under root 2 me, where E is the energy of photon. Putting this expression here, I have also derived it for you here in this lecture itself. And then put all the values which I have shown you here, and you get lambda p upon lambda e is equal to under root 2 mc square by e. Quickly, let us recap what we studied today. Today, we studied that matter wave consists of large number of particles which are traveling, consisting of group velocity and phase velocity, and the relation between group velocity and phase velocity is group velocity into phase velocity is equal to c square, where c is velocity of light, and de Broglie expression lambda equal to h upon p, lambda equal to h upon under root 2 me, lambda equal to h upon under root 2 mqv, lambda equal to 1 to 12.28 under root v angstrom. Thank you. Please subscribe my channel. For any suggestions or feedback, you can mail me at the following email ID or WhatsApp number 9810320303. Thank you.